Recording in progress.
Hello, hope you're fine. And once again, I would like to teach a new optimization algorithm, which I was introduced earlier, named as the social engineering optimizer. This algorithm is highly different with many optimization algorithm, which was developed during the last year. And now I would like to introduce this algorithm, the social engineering optimizer, which is cited many times during the two last years and published in a well-known journal in the field of artificial intelligence and engineering applications of artificial intelligence, which is a high-ranked journal. Let me start my presentation, and we'll talk about the algorithm and the codes and how and why this algorithm is very efficient and very important for solving optimization problems. Yeah, as I remember, I firstly presented this algorithm in a conference about industrial engineering, which was held in Babelsar, Lisbon, Iran. It was a very nice conference, and I enjoyed it. Yeah, I will talk about the metaheuristics, the social engineering. What is the social engineering? The social engineering optimizer, which is very well-known optimization problems. This is a well-known optimization algorithm, and benchmark functions, engineering problems, and many other tests which is done. I think the optimization algorithms can be divided into two main groups, using mathematical programming and metaheuristic or heuristic algorithm. Mathematical programming, when you want to develop optimization models using linear or integer or mixed integer programming, and when you want to solve it using mathematical programming approaches, such as Bender's decomposition, Lagrangian relaxation, and other reformulation techniques. And heuristic algorithms. And heuristic algorithms generally is divided to main groups: the single point or single solution and population-based. All of the recent developed metaheuristics are population-based algorithms. Population-based algorithms uses a set of population. You have many solutions, and you can do the search phases, intensification and diversifications, and do search intelligently. But the single point algorithm solutions are very different, because they are very fast, they are very intelligent, but there are some disadvantages, such as they need to do the search phases. However, most of the single point algorithms are low-cost search algorithms. They cannot do the intensification or diversification phases very intelligently. Therefore, this motivates this paper to propose a new single solution metaheuristics, such as name as the social engineering optimizer. There are many recent developed algorithms, and let me show you in the paper, which was previously discussed. as you can see, all of the recent metaheuristic are population-based, and there are very few optimization algorithms that simulate annealing, taboo search, variable neighborhood search, which are the single solution algorithm. The social enduring optimizer is also a single point metaheuristic algorithm. Let me talk about what is the social engineering. The social engineering is defined as enduring attacks to obtain the people or their information using some certain techniques. I try to introduce the theory of Professor Granger, who worked in the area of social engineering. He acknowledged, she acknowledged that the defense against the social engineering attacks is a common pattern, and she claimed that social engineering attack procedure has a 4-step cycle. There are 4 main steps in the social engineering. First, the training and retraining. It means that the attacker tries to train and retrains the defender, and then based on his knowledge and his benefits in the training and retraining process, he will develop an attack to spot an attack. And after the attack, for example, phishing your bank information, or it is very important how to respond to the attack by the defender. And finally, after the attacker was successful or failed, this process will be repeated, and a new way or new person will be selected to do these cycle: training, retraining, spotting an attack, and respond to this attack, and this procedure. As I told you, it is very important how to respond the social enduring attack and reacts of defender, and how much information it wishes to make streaker. In the social enduring attacks, the most important phase is how to respond to an attack, and these cycles and steps are very important, and also in our optimization algorithm, because it plays the main role. The social engineering optimizer or optimization algorithm uses the counterpart of a person and his traits, or his or her traits, for ability and concept of mathematics, sports, business, and many other aspects as a solution. You can consider a person as a solution, and his abilities or his or her abilities in different scopes, such as the personal life setting, or the sports, his or her ability in the contents of mathematical, or in the contents of music, are the main contents. The flowchart of this algorithm is defined as follows. As you can see, we first generate 2 solutions. two solutions. One is an attacker and another is a defender. Then we have the train and retrain phase, which is a procedure to provide a link between the defender and the attacker, and then the attacker will spot an attack, and the response to attack by the defender is very important. And this procedure will be repeated because the attacker trying to do many ways as much as possible to get information from the defender, from the person. And after the attacker was successful or failed, he or the attacker tries to find new person to get his or her information and as a defender. And this procedure will be repeated in our optimization algorithm. It should be noted that the train and retrain phrase is a low-cost search, similar to other single-point solutions, single-point algorithms, as a low-cost search algorithm. And we also have this phase in the social engineering optimizer. You can note that we have the train and retrain phase as a low-cost search. And then we have an intensification phase. Intensification phase to exploit a new solution, a very efficient solution, as by using an social engineering attack. And we have diversification using randomness. It means that in each iteration we use a new random solution as a defender, and this random solution will be used for training and retraining and the social engineering attack. And this step helps this metaheuristic to escape from the local optimum solution. It should be noted that the main disadvantage of local search algorithms, such as stimulated aligning or the taboo search, is that it cannot do the diversification very good, and these algorithms only do the low-cost search and updating the low-cost search for a single point solution. However, in the social engineering, we have two solutions, and this helps this algorithm to do both intensification and diversification phases. As I told you before, you can consider a person as a solution which has many variables, and the objective function is the value for this person. And the algorithm starts with two random solutions, and a better solution is selected as an attacker, and another is named as the defender. For training and retraining phase, in this procedure, we select one of the traits for defender, and randomly. This trait will be selected randomly, and then the attacker try to copy its information, its ability to change or to retrain it to the defender, and then that we check the value of the objective function. by using this lookup search procedure, we can update the value of the offender, and we can understand that how the returning is done, and a solution which has more amount of retraining will be selected as a new defender. Therefore, in this step, we select an alpha percent of variables, and then we try to replace them into the defender and update the value of the defender, its objective function, and replace the new defender in as the role of defender in this step. To spot an attack, we have used and we have simulated 4 different social engineering attacks. For example, the obtaining, the phishing, diversion theft, and the pretext. And there are also many other techniques, and we can try to simulate these procedures in an intelligent way. In the obtaining, I defined this formula for simulating this game. As we can see, after this attack from the attacker to the defender, defender tries to go to a new position as the blue color. This means that in this simple simulation, the attacker only tries to obtain the defender. In the phishing, it is different. First, both defender and attacker goes in the same way to make them very closer, using 2 different values and 2 different formulas for doing the phishing phase. In diversion theft, we have changed and we do a change for the attacker. He goes to another position, and then the attacker tries to get the information from the defender. And the pretext, it's the vice versa. It means that in this social engineering attack, the defender is going to another position, and then the attacker attacks to this position to try to get the information. Responding to the attacks is considered if the defender gets a better value, we can't exchange the old position of defender with a new position, and if the attacker if the defender is better than the attacker with regards to the value of the objective function, we can do this exchange from the new position for the defender and attacker. After a new person is selected as a defender, the attacker annihilates the defender and selects a new person randomly to repeat the social engineering steps. And the stopping condition is the number of iterations or the time interval or maximum time of simulation for this algorithm. As you can see, we have, for example, consider the time clock and then start the simulation. After training and retraining, we have considered the number of iteration for the enduring attacks, and then update the value of the defender. In the case of the minimization, a lower value is provable, therefore it's be considered. Then create a new solution to the defender, and this procedure is repeated until the clock or the solving time will be met. So as we can see in the paper, there are a huge number of tests to compare this algorithm with many other optimization algorithms. And the paper, for each enduring attack, the algorithm is divided into 4 versions. However, we can use each enduring attack randomly per iteration, and can consider that the attacker can change his or her strategy to update the information. And you can see that based on the many optimization algorithms and many sensitive allowances on the value of the parameters of this algorithm, an extensive comparison is done. At the end, we also consider an optimization problem for the supply chain networks, which is a allocation problem using 2 objective functions, and it's for the location variables and the allocation variables. And you can get more information in the paper, and note that the paper is available if you search this part. Now, this algorithm, now I would like to talk about the codes to how implement. You note that the codes are available in the ResearchGate. If you check the data for this paper, there are 4 sets of codes. This code is for solving the enduring problems. This code is for the benchmark optimization problem for the single objective function. I will download this codes. I will download yeah, the file is available. And also I will use another code for the multi-objective form. I will illustrate what is the difference in the phase of the multi-objective. The objective optimization for benchmark functions is also available here. Now let me copy these codes to this file, and we will try to extract the files and talk about the codes. In the is the multi-objective. Before the multi-objective, I think it would be better to talk about the codes for a single objective optimization. Now, so for the code, you can see similar to many metaheuristic algorithms in the MATLAB, and we will define the objective function, the number of variables, and the size of variables, the feasible space. The social engineering optimizer has only 4 parameters in addition to the number of iterations or the number of the termination criterion. And we have the alpha as the rate of collecting data for the training phase, and beta is the rate of the social engineering attacks. In the attacks formulas, we have a parameter in this beta. Both these parameters are between 0 and 1. Therefore, these parameters can be tuned. And the number of social engineering attacks, which is can be considered as a sub loop, and these parameters can be tuned as well. For the position and cost, it means that for each person we have the traits, and the cost is the attribute of the ability of the person. We have generated 2 solutions randomly, as you can see, and the better person is selected as a defender, and another is the better person is the attacker, and another person is the defender. For training and retraining phase, as you can see, based on the number of variables, we selected a random number, and note that the number of percentage of variables and random variables selected, and we do the local search and then update the objective function. And if there is an improvement, replace will be done. The social enduring attack, as you can see, there are 4 social enduring attacks in the paper, and in each case we can select one of them randomly based on the formulations that I told you. And after these social engineering attacks, we have checked quality of the objective function and defender and attacker, and finally a new defender will be generated randomly, and the main algorithm. I run this code for an optimization problem. You can see it has a very good convergence rate, and the value is very close to the 0 as the global point for the sphere function. It shows that this algorithm is very efficient. And we also check the value for the multi-objective. The only difference in the case of multi-objective is that in each iteration we will select one solution in the list of Pareto solution, and then for example, for this if we have considered 200 iterations, it means that we have 200 Pareto solutions in the list, and then we check the Pareto solutions to generate non-dominated solutions for selecting the efficient number of Pareto solutions. And finally, I selected the evaluation metrics, assessment metrics for calculating the performance of Pareto solutions. Let me run this code as well. As you can see, this is the generated Pareto solution for the 2 objective functions model, and these are the evaluation metrics for this selected Pareto solution, and this is the finished. I hope you are enjoying this presentation, and hope this information are useful for your research. Note that this metaheuristic is cited and is used in many engineering fields, and there are many papers which have, for example, that have used this application, this optimization algorithm to compare or to in many engineering fields. I'd encourage you to read the codes or read the papers which have used this algorithm, and you can, as this algorithm is a single point optimizer, you can combine this algorithm with many other population-based metaheuristics, or try to improve this algorithm using, for example, an adaptive memory, such as the taboo search. And there are many ways to improve and to do a modification or hybridization for this algorithm. And I hope you will enjoy, and do not forget to see the codes in the research guide, and hope these codes are useful. And please share this video for the persons, and try to share this paper for every student who is interested in the field of optimization algorithms, and the application of optimization algorithms in many combinatory optimization problems as discussed in the paper. And I think this line of research is very interesting, and I hope you will enjoy this line of research. And best wishes, and have a good day, and hope in the future I will be able to propose another algorithm or another video for teaching the optimization algorithms and models. Best wishes, and take care.